let's go through a couple notes today. Okay. Hey. All right. Let's take a few notes. We have the inverse trig functions to do today. The reciprocal trig functions, I should say, that we're going to graph today. We have cosecant, secant, and cotangent in no particular order. I want to go through those today. We've already seen one of them, so it should hopefully help us. But the only weird one will be cotangent, because again, tangent was a very different graph. Cotangent's very, very different. So goal today is to go through those three, and we're just doing notes today. Question?
Did you find any application for tangent?
Oh God, I forgot all about that. I'll have some for tomorrow, because we're gonna still continue this stuff tomorrow. I will have it. Hold on.
I was looking for it all weekend.
Hold on.
I was just waiting.
I totally forgot.
I'm so excited to come to class and learn what I can use tangent to do for Monday.
Mr. Ward, when are we gonna do the cum stuff and eat ice cream?
We already did that. You just happened to miss that day. So that didn't miss. All right. Hey. Okay. Let's go through a couple notes here. All right. We're on section 4.6 today. I know we're moving on to the last section. These are all the reciprocal functions now. I tried to intro it the other day. I think it was Thursday. I tried to introduce the reciprocal function. These three are the ones I want to cover today. Yes, we're doing 3 of them today. I'm going to try to do maybe 1 or 2 examples of each type. But the reciprocal functions themselves, if you had the sine function, its reciprocal is cosecant. So that'll be the first one we're going to start with. That's the one I think we did last Thursday. So I want to talk about how to graph it. How do you do it normally? What would it look like if we did some form of shifting on that, or we messed with its period or amplitude. I want to focus on that one. Second one that I want to cover today is the cosine graph's reciprocal, the cosine function, which its reciprocal is secant. So we'll look at that one. This one we have not seen yet, the secant graph, which if you understand how the first one works, you'll understand how this one works, so we'll do the secant graph. It'll look a little bit different than the other one. And then the last one, which is way, way, way different, which is the tangent function. This is by far probably the newest function we just did on Friday. But on that function itself, its reciprocal is very different. Shh, stop talking, you're annoying. So, all right. Now,
Stop talking, you're annoying. Reese.
Okay, so we're going to do the cotangent, okay? All right, that's what we're doing today. My goal is to go through at least one of each type. If we have a little more time, I'll start messing with them very, very, very much, where we start from an amplitude period, we start messing with the actual shifting up and down. The only one I'm really worried about that we'll probably spend the most time on today is the last one. Because again, these two were just so different than the others that we need to just spend more time on it. That's why we're just doing notes today, to kind of get a feel for it. Once we're through the main 3, and then we try messing with it, and we feel comfortable with that, you might have a little bit of time at the end of class. You can just kind of work on other things if you need to turn in homework today. But the goal today was to go through the reciprocals. Tomorrow we might see 1 or 2 examples of each type, but that's about it. And then Thursday, Friday we'll start reviewing. Now I know Wednesday we have classes. Just make sure that, if you check your grades online, get some late work stuff turned in. I think today's homework I'm going to try to enter tonight, because I don't have basketball and stuff, so keep that in mind. All right, let's start with the first trig function here, so the sine graph. Okay, so if we're going to do the sine function, what I always strongly recommend, if you're going to do the sine or the cosecant graph, draw the original function first, and then you can do its reciprocal off of it. Okay, the only one that's the exception will be that one. That'll be the only weird one. So that's the only difference. Okay, sine function. Let's talk about cosecant. All right, now the sine graph. Normally, what do we go to? Funny guys shaking your head further. All right,
2 pi.
2 pi. All right. The 4th hash mark is usually 2 pi. All right, that's the 4th hash mark. We cut it in half. We cut it in half again. We multiply that. All right.
2 over 5.
All right. Okay. The amplitude is normally 1 and -1. That's our normal graph. And now, when I draw a sine, this is the one that I would draw very faded if I'm doing the cosecant graph. I do want to draw the cosecant graph. Okay, this is my main goal today, is draw this one. So if I'm going to have to draw the cosecant graph, you have to draw the sine graph first, very faded, and then we're going to go off of it. So here's the sine graph. It starts at 0, goes up to its highest point, comes back to 0, goes to its lowest point, comes back to 0. If you're drawing this in your notebook, just draw it with a very dashed, faded line that you can easily erase. Okay, again, I draw the sine graph first, and that's just one period length of it. It will keep going right and left. Anytime you hit 0, like the origin, you have to draw an asymptote. So at this point, there's an asymptote right here, there's an asymptote right there, and an asymptote right here. It's any time you hit the origin line. So if we shifted this up and down, it's when it hits that new middle. Okay, so we have some asymptotes in there because we're going to draw the cosecant. The cosecant is the reciprocal. It basically goes the different directions. So if we hit a peak and valley at 1 and -1, we're going to go the opposite directions of what sine is going to do. So sine bows down, cosecant bows upwards.
Will that be acceptable in tests if we have it like
Yes.
this? Yeah.
Yep. If sine bows up, then cosecant bows down. This part in red is the part I want you to draw. I draw the original sine graph, and then I just go off of it from its peaks and valleys. So,
UN and N.
any questions with that?
No.
Now, afterward through the main 3 today, we'll come back to this one, and we'll try where we plug in some numbers. Like we try to plug in amplitude, we plug in period, we plug in like where we shift it up and down. We'll mess with it a little bit. But this is the goal, is to get the original functions drawn. Are we good though?
Yeah.
Okay, let's move on. I think we saw that on Thursday, so it shouldn't be too new to us, but it's been a couple days. All right, let's go to the next one. We're gonna draw the cosine graph. So the cosine function. And now we're gonna draw the secant graph. All right, here we go. So to draw cosine,
Gotta go out to 2 pi.
it goes out to 2 pi.
You almost said 2 pi. He thought himself.
All right, here we go. So cosine graph normally goes out to 2 pi.
2 pi.
Again, we'll go back through these here in a minute.
Pi, half pi.
Pi over 2, 3 pi over 2. All right. Now again, amplitude 1 and -1. All right. Now cosine. The normal cosine graph doesn't start at 0. It starts at its peak, which is 1, comes back down to 0, goes to its lowest point, comes back up to 0, goes to its highest point. And this, and again, I'm going to draw a very faded line. This is the cosine graph that we've been drawing since last Thursday. That kind of looks like a U. Now, again, this one does have an asymptote now. Okay. All right. So, anytime you'd hit the origin line, the zeros, you'd have an asymptote. So in this case, we have that undefined boundary right here, because that's where you hit 0. We have an undefined boundary over here, because that's where you hit the 0 line. Okay? And now, the secant graph, this one, goes off of that. So anytime you hit a peak and valley, that's where the secant graph will go off of. And it goes the opposite direction. So if this one bowed down, secant bows upwards. If this one bows up, it bows down like this. And if this one bows down, it goes up. There in red is your secant graph.
Well, you don't go the other way with the...
If it continued, if we went more than one picture length, you're absolutely right. This dash line would go down, so we'd go up, and there would be an undefined boundary again, the asymptote. But yeah, this is just one picture length of it. And again, so imagine that, like if you didn't hear Reese, these are going to go back up over here because it will continue, and then this one will go up over here because it will continue, and you have. But I'm just drawing one period length of it. Questions, comments?
No.
Okay. Now again, after we're all done with all the main 3, then what we're going to look at is when I start plugging some numbers like amplitude numbers or period numbers or shifting the origin, we're gonna come back and we'll try one of maybe each type. Okay. Are we good with the main few so far?
Yes.
Sine and cosine, did everyone have them drawn? Are we good?
Mm-hmm.
Okay. Dross, you good? I know you're still writing.
Yeah, I'm good.
Okay, spelling you good? Sam, you good? No, you're still drawing. Anyone else need? All right. Okay.
I'm just finishing up.
Oh, okay. All right. So let's now the tangent function and cotangent. This one is different. You do not use
The opposite.
the original graph on tangent cotangent because the graphs are so much different than the other ones. They are very, very different in terms of how you actually find them. So let's draw the tangent first. Then I'm going to draw cotangent next to it, not attached in the same graph like I've been doing here, where you can see both in the same one. All right, so here we go. Okay, here we go. All right, first one, we're going to draw a tangent. Now, tangent graph, this is the new stuff that was due today in the homework. The tangent function itself, this is the one kind of weird odd function that it doesn't go out to 2 pi, but it doesn't go out to just pi either, because the idea is that it's centered over the origin. It's the only one that is centered over the origin. So 2 markers are over here, 2 markers are over here. The whole distance across is pi. It's not 2 pi, like the other ones are. So it's pi all the way across the picture. So half of it's over here, and half of it's over here. And then to find those other markers, you cut those in half again. So pi over 4, negative pi over 4. Okay, so that's the new stuff we did. We do have the asymptotes on the outsides. Okay, we do have the asymptotes on the outsides. We do have the amplitudes 1 and negative 1. 1 and negative 1. Okay, now, drawing the tangent function itself, it starts in the upper right corner. It comes down, hits the first marker at the amplitude, goes through the origin, goes through the next marker, and then goes off to negative infinity. So it looks like this. It kind of looks like an S shape when you really, yeah, like a slide. It kind of looks like an S shape. Now, if we were to really like zoom out, zoom in, you probably wouldn't see the difference unless you really mess with the amplitude and you start stretching it a little bit. That's where you can actually see the real S shape. Because right now it kind of looks like just like a slanted line, but it's not. There's actually a curve to it. All right. Questions at all about the tangent function? Okay, that's the one that we had in our homework. We can mess with the amplitude, you can mess with period, and all that good stuff. I'm not really focused on that because when we go to cotangent, the cotangent graph doesn't go off of that picture, which is really weird. It's its own picture because that was its own picture. So for cotangent, it's weird. All right, here we go.
That is weird. Last one of the day. Last problem of the day.
No. Okay. Cotangent function. Here we go. All right. All right. Cotangent. It's no longer centered over the origin. It's actually a shift of this picture. So it's actually got 4 markers going that way.
It's actually like.
So it almost looks like the sine cosine graph again. We're going back to the old school ways of doing it because how the reciprocals always work. Since tangent and cotangent are also known as co-functions of each other, not just reciprocals, that means they're shifts. So it's actually taking that picture and shifting it over so that all the markers are on this one side. It still has undefined boundaries. It still has asymptotes on the outside. But the markers itself, the only thing that it actually gets right with this one is that it has its full distance here is pi still. So that's really the one thing that it does share with tangent. So the 4th marker is actually pi because I don't need to split it in half. They're all going to the right.
So it's half pi.
Then half pi,
3
pi over 4,
and
and it's 3 pi over 4.
pi over 16. So 3 pi over 4.
Okay, are we good with the 4 markers going across?
Yeah.
All right, asymptotes on the outsides. Okay, asymptotes are on the outside. It still hits an amplitude of 1 and negative 1 like always. So we'll still hit 1 and we will still hit negative 1.
Does it affect our amplitude?
Now, here's how the difference is. If you've looked at all the reciprocal functions, they've always taken their graph and went the opposite directions of them from the origin line, or from its peak and valley. Well, this one doesn't really have a peak and valley. It has an origin where it's actually crossing.
Do we have asymptote up there?
No, we don't.
Oh my.
Because on that case, why we don't, well, technically we do. Because if you look at this graph versus that one, there is an actual asymptote there. It is right on the origin. It's just, technically, it's, what we're going to be doing is we're going to be shifting our graph. So the graph has been shifted over from this one,
Oh, sure.
and it's going the opposite direction. So this is what it's going to look like. It's going to hit its first marker here, go through the middle, hit its next marker that direction, and it's looking like this.
Kind of like a.
It kind of looks like a slide.
If you want to call it a slide, that's fine. But here's the idea. Cotangent is actually a true flip. It's a cofunction and it's a reciprocal at the same time. So it is going the different direction as tangent. It is a negation of tangent. So it's flipping the graph over. It is a true negation of it. And it's been shifted horizontally 90 degrees.
That one's my favorite.
So, as you can tell, very different graph. Like they don't even look the same because it's not centered over the origin. It's actually been shifted over like the other problems have. But the only common thing is it's going out to pi, because the period lengths are pi, but then the graphs are complete flips. That's a little bit different. Alright, goals today, because we have about 20 minutes here. I want to do one problem where we try to mess with the numbers here. Okay, where we plug in an amplitude, we plug in a period, we plug in a shift up and down, and we try to mess with each problem.
Oh my.
Okay? Now, it's up to you which one we want to focus on first.
No.
Now, so hey, do we want to focus on, do we want to go back to secant or cosecant, or do we want to start with cotangent and kind of work with
We'll
that?
start with secant.
Okay,
My favorite's
so
Cosecant.
I think I'm going to start with this one because it's already drawn on the board,
Oh.
and then we'll go backwards.
It was up to us.
Okay, yeah, but I heard first person I already heard. They said what I wanted to.
What?
It was your choice, up to them now. So I heard what I wanted.
Equals pi, correct?
Alright.
Smells like dead.
Alright, here we go. So let's do a cotangent function. Let's plug in some numbers, and yes, I'll give you guys kind of leeway what you want. 7, 2, 4.5.
No, that's weird. How about 4?
4.5. Alright, I'll change that here in a minute.
How about 4.5?
Alright, now hey. Okay, what we're going to do is we're going to draw the cotangent graph. Our period length has been affected. We'll see that here in a minute. Our amplitude has been affected, and we are shifting this thing up 7. Okay, so it's going to look like this picture, but it's going up, and it's being stretched, so it's going to be stretched a little bit taller, and these 4 markers have now changed.
Oh my.
So the 4.5, the only thing I need to change on the 4.5, I want to make that improper. So 4 times 2 is 8, plus 1 is 9, so this is 9 halves.
Hold on, that's funny. 9 twos.
Okay, 9 halves. Alright, so now, the normal period length of cotangent is normally pi. That's the normal period length, right? So, what we do, we divide by the number that's in front of my x. So we're going to divide by 9 halves. When you do that, when you divide by 9 halves, it flips over, and it's 2 over 9 times pi, which you can just put the pi on the top, so it's 2 pi over 9. That'll be the 4th marker going across. And then we'll do all the math to actually figure out what those are. Any questions right now on how I found the period before I start drawing?
So you just multiply it?
So yeah, you flip it over. You're technically dividing by the fraction, but you do the reciprocal and you multiply when it's a fraction like that.
I think I'm showing that.
Okay. Okay, let's go through the drawing here. Now I want to leave that up on the board, just so we can compare it to the original. Now my picture won't look different, but not crazy different anyway. But you'll definitely see that we're shifting up and down, all that. So on my picture here. There we go. All right. So in my picture, we're going to be shifting it up 7. Okay. We're shifting up 7. So this spot right here is the new origin line. I'm going to mark origin. So this is kind of where your 4 hash marks are going to go across. So we're gonna have 4 hash marks right here. Now again, why? We had a +7 out front, it's shifted my graph up 7. From there, my amplitude is 2 above that and 2 below that. Because again, my origin line was shifted up to 7. Now the 4 hash marks going across. My 4th marker was 2 pi over 9. Then I cut that in half. Cut that in half again. And then I multiply that one by 3.
Oh my, that's a big number.
5 or 6.
Pi over 6. 2 pi over 9.
So it's just increasing.
Okay, so we moved my graph up 7. My amplitude has been affected, and now we're going to draw this. So I still have the asymptotes on the outside, because it is a cotangent graph, so it still has those undefined boundaries. It's going to start at its highest point, come down to its first marker at its amplitude, hit the middle, hit the next marker at its next amplitude, and then it's gone, and here it is.
That looks like a shoot.
I prefer this.
Okay, questions on cotangent? Alright, everyone's got, how I got my markers. Everyone has my amplitude, what those are. The only thing I didn't really throw in here is if we throw a negation, like a negative sign in there, it could flip the graph over.
That's pretty simple, right? Just flip.
If we do, I'll do one tomorrow. I'll have to look at the homework that I assigned because I'm only picking a few problems of each.
Alright.
Would you ever give us a fraction like that on the test?
Like a
Fraction,
2 pi
oh, yeah,
over 9.
that's fair game.
Yeah, 2 pi over 9 is a
That's
fair
fair
game.
game.
She said I should memorize 2
Fractions
pi
are fair
over 9.
games.
Okay,
Is
so
it
no
fair
fractions,
game or will you
no
do it?
questions.
That's two different
No
things.
questions on the test.
No
Will you
questions
do
on the
it?
test.
I mean, it could be fair game, but
Just
will you
statements.
do it? Is
Done.
Say this.
Alright. Hey, everyone's got it?
Yep.
Yeah. I think what you should do is you can
Moving
give
on.
us a graph, and we should just
Alright,
have to say which
Cosecant.
one they are.
That's pretty okay.
Okay, cosecant?
We should have math to do the test.
You know what? I think we should do secant.
No. Alright, here we go.
Well, this is a lot for me.
Yep. Oh, no, it looks like a slide.
Alright, here we go.
So hard.
Okay, we're gonna go to cosecant now. Okay, we'll get some new numbers here. Alright, so we're gonna go to cosecant. Alright, I need some numbers around cosecant.
7, 5, and 2. Because it's prime.
Alright, here we go.
It's nice and prime.
Prime numbers are good numbers.
Alright,
Nice and
What?
prime.
Change 7 to
No, it's prime. 5 and
We
2.
used 7
Prime
last
numbers are the best
time.
numbers.
Yeah.
we'll be fine. We'll use 3 next.
Let's use 203.
Oh, well, also need to use 7.
Alright, hey. Okay, we're gonna do cosecant. So on this one, since I'm doing cosecant, these are the ones that are required. You need to draw the original function, and then when we do the reciprocal, which is this one, then you go off of it. So the cosecant graph is actually the reciprocal of sine. So I know this seems a little weird. I'm gonna draw the sine of 2x
Oh my.
with the 5 out front and the +7 first. This is the first thing I'm gonna draw, and then I can do cosecant off of it. That's how I normally start my problem. That's what I was doing earlier. So, this thing is being shifted up 7. It's got an amplitude of 5 from there, and then its period for sine is normally, the period length is normally 2 pi, but we have to divide by the number in front of x, which is 2, so we're going to be going out to pi. So that'll be the 4th marker once we have this thing shifted and we have my amplitude figured out. Okay, so here we go. 1, 2, 3, 4, 5, 6, 7, and then we're going up 5 from there. 1, 2, 3, 4, 5. So this is 7, right? 1, 2, 3, 4, 5, 6, 7. And we're going to go 5 from there.
So 2.
6, 5, 4, 3, 2. And then up from there, which is 12. So those will be my peaks and valleys. My origin line is right here, because we shifted my graph up 7. And the 4 hash marks are going off of that shift. So again, it shifted up 7. The amplitude will be 5 up and down from that origin line. And the 4th hash mark going across is pi. We cut that in half.
Pi over 2.
We cut that in half
Pi
again.
over 4.
And multiply by 3.
Yeah.
Okay? And I'm going to draw the sine graph. Now when I draw the sine graph, I draw it nice and faded. I don't want to draw it very, very dark, because I will technically need to erase it once I'm done, because I wasn't asked to draw this one.
Do we have
I draw it in there
Do we have
so
to
I can
draw
see
it?
it. You won't have to erase it, but you have to early fade.
Don't do it.
But I will erase it so you can see this. So, alright, Sine graph starts at 0, goes to its highest point, comes back to 0, goes to its lowest point, comes back to 0. Here it is. Okay, there's the sine graph. Anytime we hit 0, there has to be an asymptote there. So there is a undefined boundary right here, because that's where I hit the origin. There's an undefined boundary right here, and there's an undefined boundary right here. And then my graph will go off the peaks and valleys.
So it goes up first.
So it's going up first,
It looks like a U first.
and then it's going down second.
Looks like somebody spilled their bowl upside down.
Okay, there you go. The part in blue we do not need. The green undefined boundaries do need to be clearly marked. All the 4 hash marks need to be marked, and then the peaks and valleys would need to be marked as well from the origin line. Now I know some people like to draw the origin, then they just label it 7. Like they just draw the normal graph, and then they just say this is 7, and they go up and down. I always avoid that because some people they start initially by putting 7 here, but then they don't get the right numbers because they don't think about where they're at. They'll start going up 1, 2s, they don't even think about what they just marked 2 seconds ago. So just kind of make sure that when you're drawing this, you know that you have to draw the original function first, then you can do the reciprocal off of it. Okay, last graph of the day, we're going to do secant, then we're done.
No, that one does not look like a slide.
Okay, before I move on, are we good?
Yeah. I'd say.
Okay, alright.
Yes.
Yeah. Is everyone good though?
Yeah. That hurt, and I got sick. Oh.
No, they were already open when I dropped it.
You guys are talking too much, stop.
You are annoying.
Okay, alright. One of the numbers I heard earlier, let's go with the -3.
Let's do 7.
No, I'm not doing 7.
5.
13. 13 is prime.
Secant.
231. How about 31?
3/5.
31. He did it.
80%.
I'll
I'll put the 5 in there, there you go.
X. Do we do beta?
Alright, hey, here we go.
Which one is this?
X.
This is secant now. Alright, last problem of the day. Once we're done for the day. Alright,
Yeah.
first thing, when you draw this, we have to draw the cosine graph. And we're going to have all the same numbers involved. Because how you find it's reciprocal is you have to draw the original graph of cosine first, then we can flip it over and go from there. Okay, so on this one, the normal period for cosine is normally 2 pi, but we're going to be dividing by 3/5. That's the number in front of my x.
That's all.
So if you do a reciprocal here, that would be 10 pi over 3, because you'd have to flip this over and the file would be multiplied on the top. So that is the 4th marker on this particular problem.
Oh, that's all weird.
And we're going to draw it as normal. So, okay. So it looks like we're shifting down 1, 2, 3. So this is my new origin line.
Yep. 5.
And again, it's because it's negative, we went down. The amplitude from there is going up 4, so I will hit a peak of 1, and I will go down 4 from there,
-7.
which is -7.
Gucci.
That'll be my highest and lowest point. The origin line itself, that's where your 4 hash marks will be. There's imaginary 4 hash marks going across.
Half of that, yeah.
So 10 pi over 3 is the 4th marker.
Oh, that's goofy.
Okay,
Half
we
of
cut
it.
that in half, that's 5 pi over 3.
Cut that in
Cut that in
half.
half again, which is 5 pi over 6.
Oh my.
And then we multiply that by 3,
15
which
pi
is
over-
5 pi over 2.
Oh.
15 pi over 6, which I
Yeah, I
simplified.
was gonna simplify it.
Again, how I'm doing that so fast, when you divide by 2, you're technically putting a 2 on the bottom,
Do we have to simplify it?
and I always simplify.
Do we have to?
Yes, I want you to simplify.
Okay.
I want you to simplify, especially on this one. You should be getting to the point.
And
where
we
you-
can't put decimals down.
Computers.
Alright, at this point, I have to draw cosine. Cosine, normally starts at its tallest point, comes back to 0, goes to its lowest point, comes back up, goes to its highest point. Okay? Anytime I hit the origin line, I have to have the undefined boundary there. Anytime I hit the origin line, I have to have the undefined boundary there. All right, and then I can draw the secant graph off of that. So it's going to be going up first. It's going to be going down second. And it's going up third. There you go. There's your secant graph. Okay. Rest time today is yours. You can work on the assignment that's due today. If you haven't turned it in, remember book checks tomorrow. Make sure you have a book with book covers on it. I'll be checking that. If you know you're going to be gone Thursday, Friday, start warning your teachers today. I've already been warned once.
I'm gone Friday.
Okay, good night. So
I will be here.
So.
What if you fall ill?
Unless I fall ill.